Hey guys, I just thought I would throw together a little primer just to help remind us how to do these formulas in a spreadsheet. It occurs to me that this could be a source of anxiety with your lab reports if you're not, completely comfortable with if you don't remember the details of entering formulas. So I'll take you step by step. So this is just a set of data. It's just a sample set. This is not your class's data. Okay, so this is not the data that you're going to use. It's just this is just a sample to illustrate the formulas. Okay, so first thing I want you to notice is right here, this row. This is the row of your table for the class data where we're keeping the accepted values. And right now I'm not very happy with how the table is displaying my my numbers. So aluminum should be 0.900. So if you look up the accepted value for specific heat of aluminum, it's 0.900. And right now this spreadsheet is only displaying 2 decimal places. Okay, well we can control that. So whenever you get a value that's not displaying the way you want it, you have control over that. So you come on up here to the menu, and you see there's these 2 arrows, the arrows going to the left. That will allow you to decrease the number of decimal places. The one going to the right increases. So when I click that, notice I now have 3 decimal places, and that's exactly how I want it displayed. Now let's go over to copper. Copper should be 0.385, and right now it's rounding it to 0.4. Also notice when I click on the 0.4, when I click on a cell up here on the function line, it's displaying the value that's actually there. Okay, so when I click on that, this is what's actually there. Okay, so you can kind of see how it's rounding it. So anyway, let me just highlight those two guys, add 2 decimal places, and there. Now it's properly displaying. This one, it's even more severe. This cell is rounding my accepted value for lead to like the nearest whole number. So the actual value that I typed in here is 0.128. That is the accepted value for lead to 3 decimal places. And even though I typed that in, there was something about the formatting of this particular cell that it took it all the way down to the nearest whole number, which is 0 actually. Okay, so I'm going to click on these 2 cells, and I'm just going to click 3 times. Okay, so just to make sure I've got 3 decimal places. Okay, so that may be one thing that is giving you some frustration. So I just want to make sure we talk about that. All right, now let's calculate the average values. These should be pretty straightforward. All right, so obviously what we're doing is in this cell we're going to take the average of these class data. Okay, and so we click on the cell, and the first thing we do when we're entering a formula in a spreadsheet is we type the equal sign, right? So as soon as you type an equal sign in a spreadsheet, the spreadsheet kind of wakes up and says, oh, we got a power user here. So now we type the name of the function, which is just simply average. Okay, and then we have to open the parentheses, and inside our parentheses, this is where we specify the values that we're going to take an average of. And so you can do this with your mouse. If you have a mouse, or if you have a mouse pad, you just swipe this with your finger, and then don't forget to close the parentheses, and then just hit enter. And when you hit enter, you should get 0.707. Okay, for these data. Now you might want to try this with your own, with the period 3 class data, and try that and see if you can get the average value for that data set. At any rate, let's see. I just wanted to mention that when you look inside the parentheses, when you highlight the the values that we're averaging, okay, what it does is it takes the address, and since it's going from B5 down to B14, to indicate a range of cells, it uses a colon. So do you see the colon there? So that means B5 through B14 inclusive. That means including B5 and B14. Okay. I don't like the formatting. It took it down to 10 font. We want that to be 14, and we would like this to be centered, of course. Okay. Now, we could do the exact same thing for the next cell, right? You could type in equals average da 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 da, but you know that there's this really super nice trick in spreadsheets, which is you can just grab the lower right hand corner of the cell and just drag it across, and it copies the formula for every column. Okay, we would like these values to be, I'm going to say, let's round these values to 2 decimal places. That would be plenty. Okay, so this is kind of how it would look like on my spreadsheet. Okay, accuracy. We are measuring accuracy by using the percent error formula. Okay, so that is, if you need to review what the percent error formula is, go ahead and look in your notebook. But it's basically, it's the accepted value minus experimental, absolute value of that difference divided by accepted times 100. Okay, so I'm going to type my equal sign. That's ABS for absolute. My accepted value is right here, and then I subtract the experimental, which is the average of all the experimental values, close my parentheses, okay, then we're going to divide by the accepted value, and then multiply by, multiply, which is the star key, times 100, and then I just hit enter, and there you go. So for my data, I got 21.4% is the error, and then I just drag that across all the way over. Okay, these error values are, obviously not too good. You hope for values that are 5% or less, if everything's going well. Okay, and finally, let's do the precision. So we're going to, our measure of precision is going to be what's called the percent standard deviation. Okay, so in words, the formula is, it's the standard deviation of all the data divided by the average value, and then the whole thing multiplied by 100 to turn it into a percent. The standard deviation, if you remember, is a measure of how scattered the data are. Okay, so if all of these values were 0.9, if it was just 0.9, 0.9, 0.9 repeating all the way down, then the standard deviation would be 0, because there's no scatter in the data. The range is 0. But as the data starts to jump around a little bit, the standard deviation starts getting bigger, and the more widely spaced out the data are, the bigger the standard deviation. Okay, so that's what we're trying to get a handle on. So we type equals, and then standard deviation in a spreadsheet is STDEV, open parentheses. Again, you got to give it all the data, close parentheses. Okay, so now it's going to take the standard deviation of all of the individual specific heat values, and we divide that by the average value. And then to turn into a percent, we say times 100 and hit enter. And looky there. Okay, 29. Is 29 a good number? Not really. Again, 5% is kind of what we're hoping for, 5% or less for the percent standard deviation. So these values, these were obviously not some of our better efforts. Especially when I look over here at the lead column, the lead data, I'm noticing this value right here. I'm not sure what happened there. This was something catastrophic must have happened there, so that's definitely an outlier. And then this number right here is certainly an outlier. I'm just curious to see what would happen to our percent error if we, I mean, don't do this on your table, but I'm just, curiosity is getting the better of me. Look at that. If we take out just those two outliers, look what happens to our percent error. It goes down all the way down to 1%. Let me put, yeah, see, when I put this guy back, the error goes up to 65%. So it's really sensitive to just one number. Okay, folks, so I hope that this has, you can kind of see it happening in real time. I hope that helps with your own spreadsheet, and then when you've got everything set, then you just kind of like grab the data, Control C, and then you can paste it right into your report. Okay? All right, so email me with any questions, all right? Thanks and good luck.